Operations with functions. Combining functions using the arithmetic operators is straightforward. Here's how to represent the operations using function notation. Here's an example. Let f of x equal x squared and g of x equal the absolute value of x. Write the sum, difference, product, and quotient of f with g. So the sum, f plus g of x, equals f of x plus g of x, which is x squared plus the absolute value of x. The difference would be f minus g of x, which would be x squared minus the absolute value of x. The product would be f times g of x, and that is x squared times the absolute value of x. And the quotient is f divided by g of x, which is x squared divided by the absolute value of x. Note, there are no surprises when combining two or more functions. The notation is clear and unambiguous. Example, let f of x equal the square root of x and g of x equal 2x plus 1. Evaluate each expression. F plus g of 9. So f plus g would be the square root of x plus 2x plus 1. And we're going to then plug 9 in. So that would be the square root of 9 plus 2 times 9 plus 1. So that's 3 plus 18 plus 1. So that is 22. Next, f minus g, square root of x minus 2x plus 1. So that equals the square root of x minus 2x minus 1. If we plug 4 in here, we get the square root of 4 minus 2 times 4 minus 1. That's 2 minus 8 minus 1. So that's negative 6, negative 7. All right, f times g of 16. So square root of x times 2x plus 1. So if we plug in 16, we get the square root of 16 times 2 times 16 plus 1. So that would be 4 times 32 plus 1 is 33. And then finally, f over g of 1. So square root of x over 2x plus 1. So that equals the square root of 1 over 2 times 1 plus 1. And we'll move down here. It's 1 divided by 2 plus 1, which is 3. And here are all of the answers, which are all correct. For this one, we had 4 times 33, which is 132. So, yep, we got these all correct. Constant coefficients can be added to the mix. Here's how to represent the operations using function notation. In this example, we're going to let f of x equal x squared and g of x equal the absolute value of x. Write equivalent formulas without using f and g. So the sum, we have 2f plus 3g of x, so 2 times f of x plus 3 times g of x, and that's going to be 2 times x squared, because we can just plug x squared in for f of x, plus 3 times the absolute value of x. All right, for difference, we have 4f minus 7g of x, so 4 times f of x, which is x squared, minus 7 times g of x, which is the absolute value of x. So that's 4x squared minus 7 absolute value of x, like that. All right, product, we have 5f times 2g of x. So 5x squared times 2g, which is 2 times the absolute value of x. And then finally, 6f divided by g of x. 6x squared divided by the absolute value of x. And here are all of the answers. On the previous problem, we had left this as 5x squared times 2 times the absolute value of x, but you can then multiply those coefficients together to make 10, and we got them all right. Here's another example. Let f of x equal 1 minus 2x and let g be given in the graph. Evaluate each expression. F plus 3g of negative 1. So we can rewrite this as f of negative 1 plus 3 times g of negative 1. So f of negative 1 is going to be 1 minus 2 times negative 1, which is 3. So this is going to equal 3 plus 3 times g of negative 1. G is in the graph. G of negative 1 is 2. So 3 times 2 is 6. So the answer here is 9. Moving on, we have f minus g of 3. So f of 3 minus g of 3 equals, all right, so f of 3 is 1 minus 2 times 3. This is 6. 1 minus 6 is negative 5 minus g of 3. So g of 3 is 1, 2, 3, 0. So g of 3 is 0. That's easy. So then 0. So the answer here is negative 5. Moving on, 2 times f of 4 times g of 4. So f of 4 is, all right, let's see, 1 minus 2 times 4. 1 minus 8 is negative 7 times 2 is negative 14 times g of 4. So g of 4 is 4.5. All right, so that's the answer for C. And then moving on, g over f of 2. So g of 2 divided by f of 2. G of 2 is negative 1 divided by f of 2. So we have 1 minus 2 times 2. 1 minus 4 is negative 3. The answer is 1/3.